Welcome, guys. So today I'm trying to quickly introduce the scalar triple product and the vector triple product, and basically follow this mathematical physics method physics for this often. Be sure to subscribe to my channel. Okay, so the first easy thing is a scalar triple product. Somebody give you a three vector, basically ABC. They are all three-dimensional vector, and you can define the B cross C will be another three-dimensional vector, and the A cross, so A dot B cross C will be another scalar. So given a vector and three vectors, and return a scalar. Okay, so the first result is that the A dot B cross C is basically this. And this is easy, right? Because one can just prove that the B cross C can be written as the BYCZ, CYBZ, right? X plus some factor Y plus factor Z, and then you do the AX, and then we inner product with A. So the first term will be this term. Second is this, third is this. Okay, so this is, you can just write it as the three vector and put into a determinant. Okay, so this is the determinant. And so we also know that if you exchange two rows, then the determinant will be there will be a minus sign. So you can fix this to position and do the second permutation. So ABC, BCA, CAB, right? But if you only exchange two, for example, you exchange C and B, then you get minus sign. Also, you have this B dot A cross C, because I only change these two, and also you can change these two, get minus sign CBA. Okay, so this is the trivial things. Okay, now we move to a vector triple product. So somebody give you a three vector ABC, right? So B cross C will be another vector, and then you cross A, then you will be another vector. So you have this. Okay, so theorem is that actually A cross B cross C can be written as these two. So this is the first non-trivial things. So one thing you can just directly prove is you can do expansion, right? But another way is that if A cross we know that A cross B, the ith component for A cross B is summation epsilon ijk, ajbk, jk, right? So that means A cross B can be written as epsilon ijk. EI is the ith directions, basically I is xyz. Okay, ajbk. Then let me just remind you guys that epsilon ijk is basically 1, -1, or 0. If ijk is belongs to like 1 to 3, 2, 3, 1, 3, 1, 2, it's 1. Then if ijk belongs to 2, 3, 1, 1, 3, 2, 2, 1, 3, 3, 2, 1, that's -1, then else is 0. Okay, so so now B cross C can be written as this. Okay, B cross I should say that the K component, right? So A cross B cross C is basically EI epsilon ijk aj, and so this is the B cross CK, right? So we just use this formula. Then we change B cross C, expand B cross C as this, right? And then we combine all of them, so we get IJPQ, EI, BJ, BPCQ, and this term. Okay, so one formula we can use here is that if there is a 2K here, we can write it as delta IP, delta JQ minus delta IQ, delta JP, right? So that means these two, right? We can write delta IP, delta JQ minus delta IQ, delta JP. And then you can do the expansion. So you see this, right? So this BPCQ, there is a delta IP and JQ, right? So this can be delta BICJ, AJEI. So it becomes this minus delta IJ, summation IJ, EI, AJ, B, right? Now P can be become J, right? Q can become I. right? So combine these two, we get the bi and the a dot c. So this term is a dot c, and this is c a dot b. So finally you get this. Okay, and the Jacob identity is also easy. Suppose we already know this because this can be written as b a dot c minus c a dot b plus c b dot a minus a b dot c. So basically use this formula 3 times. And you can find that they all cancel with each other. Yeah. Okay, so it's 0, right? Okay, so additional to identities that people also like to talk. Let me give you a quick proof. Suppose this, right? Let's prove this first. So suppose this is E, right? So by the formula we have C E E cross E dot D minus D C dot E, right? And then C A cross B dot D minus D C dot A cross B. Okay, so and then we can fix the position and do the cyclic. So this is a we can remove as a B cross D dot C minus D, and then we do the cyclic. So we CAB become ABC B dot C. Okay, and then we sorry, this is A. Okay, so now you see this is exactly this, right? This term is this term is this. Okay, and we can also do the same thing, right? So this is E dot C cross D, and then we do the cyclic permutation, so we can get C. Let me see, C dot E cross D. Sorry, so this is E dot C cross D. This is C dot D cross E. Okay, so cyclic, right? So CDE. Yeah. So then this is C dot. So D cross E is basically what is D cross A cross B. So it's A B D minus B A D. Okay, so it's A dot B cross B dot D minus B A dot D. So the first term is A dot C B dot D minus C dot B A dot D. So it's exactly the same things. Okay, that's it. So that's it, the very short introduction, and I also proved some basic identity of the vector and scalar triple products. Okay, and then next time we can talk about the differentiation and vector operations, the gradient, divergence, and others. And I will see you guys in the next video. Thanks.